Good morning, chemistry students. Here is the end of your Chapter 7 notes over Section 2, the mole roadmap. We're only doing Sections 1 and 2 in Chapter 7. And really this little section is a review. So the mole roadmap. Basically, to solve all of the problems you're going to be asked to do in Chapter 7 and to kind of get started on the problems we'll do in Chapter 9, you need to know your conversion factors. That's why you've made your chemistry toolkit. So remember way back when we started Chapter 7, we talked about the fact that there were 3 different ways to measure matter. We could measure matter by counting. Right? You might count the number of people in the room. You might count the number of desks. You might count the number of apples you buy. You could measure matter by mass, right? You might buy 5 pounds of potatoes. You buy your meat by mass. You buy some of your fruits and vegetables by mass. And the last way that you could measure matter was by measuring volume. Again, things that you buy by volume, for example, a gallon of milk, orange juice, your gas. The mole, remember, relates to all 3 of these. So you need to be familiar with the conversion factors that relate to count, mass, and volume. There are 5 total. First, we'll talk about the count ones. So the count ones are the ones that involve Avogadro's number and 1 mole. So we have 6.022 times 10 to the 23rd molecules. And remember, molecules are the representative particle of a molecular compound. So then we have 1 mole of molecular compound. That's one of our count conversion factors. Another one of our count conversion factors, and remember we have 3 here because we have 3 different kinds of substances. If we have 1 mole of ionic compound, then we have 6.022 times 10 to the 23rd formula units, because remember our representative particle of an ionic compound is a formula unit. Our last count conversion factor is when we have 1 mole of element. Then we have Avogadro's number, 6.022 times 10 to the 23rd, atoms, because the representative particle of an element is an atom. So again, these are your count conversion factors. So what about then our conversion factors that we use for mass? Okay, so our mass conversion factor, sorry about that. All right, so our mass conversion factor. Now that one, remember, has a special name. That one's name, sorry about that. That one's name is molar mass. And our conversion factor for molar mass is some number of grams of a substance over 1 mole of that same substance. Again, remember, this number here comes from our periodic table. And to get that number, we have to correctly have written the chemical formula for our substance. Okay? So that brings us to a good spot for a little quick review, right? When we talk about a molecular compound, how do we know it's a molecular compound? It's 2 nonmetals. How do we write formulas for molecular compounds given their name? Remember, the prefixes become subscripts. Ionic compounds, how do we know a substance is an ionic compound? It's made of a metal and a nonmetal, or it has a polyatomic ion in it. How do we write the formula given the name of an ionic compound? Symbols, charges, crisscross, lowest whole number ratio. Okay, so we have to have written our formula correctly to get the correct number for our molar mass, because we're going to add up the average atomic masses of all of the elements in the compound. Okay, if it's a compound, to figure out its molar mass. So again, this is our second way that we can measure matter. Okay, mass with molar mass. So our last way to measure matter, okay, is to talk about volume. And again, that conversion factor has a special name. It's molar volume. And the conversion factor for molar volume is 22.4 liters of gas over 1 mole of that same gas. Now remember, to use molar volume, we have to be at STP, that's standard temperature and pressure. That's a temperature of 0 degrees Celsius and a pressure of 101.3 kilopascals, or 1 atmosphere of pressure. Okay, but this is our molar volume conversion factor. So again, our tool for volume is this molar volume. So using these 5 conversion factors, you can do any problem. Notice what all of them have in common here. Okay, what we're converting to every single time is mole, 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 right? So in general, we're always going to be talking about, okay, converting things to moles. Almost all of these problems are going to involve converting things to moles. Now, there was one other tool that you have on your toolkit that we talked about, because sometimes, again, your book is going to kind of try to trick you, and they're going to ask you about the number of atoms in a compound. And remember, anytime we have a compound, so one either molecule or formula unit of a compound, to get the number of atoms, we have to count them or add them up. So to give you kind of, again, a quick little example of what I'm talking about there, remember we talked about that in 1 molecule of carbon dioxide, okay, there are 3 atoms, because there are 2 oxygens and 1 carbon. And remember, I can't, even though, and here's what kind of sometimes gets people, is they look for a tool that has moles and atoms in it, and they see moles and atoms, but to use this moles and atoms one, I have to have an element. If they're asking me about atoms and it's a compound, I'm going to have to use this tool here. So using these tools, you should be able to do your homework assignment, which is on page 186, questions 25 and 26. Remember, with the assignment, there is a key posted, the textbook version of the key. I will make a key also showing all of the work, like your work should be done on your homework. And I will also make a video if you are struggling with the homework, where I will kind of talk through how to do the homework. So one way or the other, you should be able to get some assistance if you need it. If those things don't work, again, remember, feel free to send me an email or contact me. Have a great day and enjoy your holiday weekend. I'll see you on Tuesday, or I'll talk to you Tuesday. I probably won't see you, but I'll talk to you on Tuesday. Have a great weekend.